Before we get started on working through some problems, here's a short little reminder of something. So first reminder is that if you have b to the c equals a, you can rewrite that as log base b of a equals c. So remember, if you're ever bouncing back and forth between these two, you can remember that you always start at the base, go around the equal sign, and then land back in the hive. So that would be log base b of a equals c. And if you wanted to go from log to exponential, you'd start at the base again. Remember, you have to go around the equal sign and then back. So it'd be b to the c equals a. Now, the other thing I wanted to point out before we get started on some examples is that there's two important logs. One of the logs is log base 10. So log base 10 is used so often in science because of the metric system, it actually gets its own notation. This is referred to as just log of x. Okay, so anytime you see just plain log x, the base is implied to be 10. The other log that shows up so much because it's a natural number is log base e of x, which we rewrite as the natural log of x. So anytime you see log of x, the implied base is 10. Anytime you say natural log of x, the implied log is e. So let's do some examples with this. Okay, so let's blank out the screen real quick. Great. Alright, so for example, let's say I wanted to figure out what the natural log of e to the third was. Okay, so what this is actually log base e. So if we wanted to try to work this out by rewriting it, that would be e raised to the question mark equals e to the 3. So this is the same thing as e to the question mark equals e to the 3. So what power do you have to raise e to in order to get e to the third power? Well, you have to raise it to 3. So the answer would be 3. Okay, the natural log of just plain old e, well, that's e to the first, so we have to raise e to the first power. And let's say we want to do what's log base 1000. So what this is asking, remember that this is an implied base log 10, so even though we don't write it, that's what we're implying. So 10 to what power equals 1000? Well, 10 to what power equals 1000? Well, I know 10 to the first is 10. 10 to the second is 100. So the answer to this one is 3. Okay, great. So let's look at some other examples working with logs. Okay, so some of these examples are going to be just straight from the homework. So for example, let's have f of x equals log of x. Okay, and we want to evaluate f of x when x equals 10 to the third, 1, whoops, and 1 over 10. Okay, so what this means is I'm going to take these values and plug them in for this x. So the first one, we want to know what log of 10 to the third is. So remember, this is implied that the base is 10, so that's going to be 10 to the question mark equals 10 to the third. So that would have to equal 3. Now for the next one, we're going to plug 1 in to our functions. We're going to have log of 1. So again, the implied base is 10. So what power do I have to raise 10 to in order to get 1? Well, I would have to raise it to the 0 power, because anything to the 0 power gives you 1. Alright, and last but not least, what is log base 10 of 1/10? So, let's see, 10 equals 1/10. So how can I write this 1/10 so that it's a power of 10? Well, if I want to rewrite that as a power, I can say that that's 10 to the negative first. Because remember, the negative gives you the reciprocal, so I would have to raise this to the -1 power. Okay, great. Let's look at some more examples. All right, let's look at writing between log and exponential form. So let's say that we have log base 8 of 8 equals 1. Let's say we have log base 8 of 512 equals 3. And let's say that we have 8 to the 2/3 equals 4. Okay, and let's say that we have 8 to the -2 equals 1/64. Okay. Now, if we want to rewrite this as an exponent, we're going to start at the base, and we have to work our way around the equal sign, and then back into the hive. So that's going to be 8 raised to the first power equals 8. On this one, we're going to have 8 raised to the third power equals 512. Now on these ones, we have to go backwards, so we want to take the exponentials and write them as logs. So that's going to be log base 8 of 4 equals 2/3. All right, now on the side here, I'm just going to write this little note. So 8 to the 2/3, what that's doing is that you're taking the cube root of 8 squared, and that equals 4. All right, now 8 to the -2 equals 1/64, so that's going to be log base 8 of 1/64 equals -2. Great, so that's how you bounce back and forth between log and exponential forms. So remember, it's all about the base. So you start at the base, work around to the equal sign, and then back to the inside. As well, if it's easier for you to remember this way, just remember if you have b to the c equals a, that's the same thing as saying log base b of a equals c. So you can always go back and forth by using this setup. Okay. Good. Let's just do a couple more of these, working with these. And let's do some where we don't have actual numbers, where we just have symbols. So let's look at, for example, log base 2 of 5 equals x. Okay, and let's look at natural log of x plus 3 equals 9. Let's look at 3 to the x equals 100. And z to the third equals y plus 7. So if it's in log form, we're going to want to write it in exponential. If it's in exponential form, we want to write it in log form. So this one will be 2 raised to the x power equals 5. So 2 to the x power equals 5. This one, remember, if we have the natural log, then the implied base is e, so that's e raised to the 9th equals x plus 3. So e to the 9th power equals x plus 3. Remember, we're just rewriting them as an exponent, so we don't actually need to solve for x, just leave it like this. This is already an exponent, so we want to rewrite it as a log, so it's going to be log base 3 of 100 equals x. And for this one, it's going to be log base z of this whole thing, y plus 7, equals 3. So log base z of y plus 7 equals 3. All right. Great. Good. So let's go ahead and do one more example. Okay, so let's say that we want to evaluate some expressions. So first, let's say that we want to evaluate log base 9 of 9 to the 31st power, so super big number. And then let's say that we want to evaluate log base 81 of 9. And let's say that we want to evaluate 3 to log base 3 of 9. And 4 to the log base 4 of 21. So here's the deal, is on this one, it's saying, hey, what power do I need to raise 9 to in order to get 9 to the 31st? So that's, what power do I need to raise 9 to in order to get 9 to the 31st? Well, you have to raise it to the 31st power. So the answer would be 31. Now on this one, it's saying, hey, log base 81 of 9. So what do I have to do to 81 to get 9? Well, I know that the square root of 81 equals 9, but what power is that? Well, that's the same thing as raising 81 to the 1/2 power. So my answer would be 1/2. Okay. Now, before we move on to this one, I just want to point out two things that this has in common. If you ever have log base b of b to the nth power, logs and exponents are actually inverses, so these guys are going to cancel out and you'll get just n back. So here we could have gotten to the answer by just canceling the log and the 9, and we would have still just gotten 31. Alright, so for the next one, we're going to see something kind of similar happen. So first we're going to start with the exponent, doing order of operations. So log base 3 of 9, what's that? What power do I need to raise 3 to get 9? Well, I have to raise it to the 2nd power. And 3 to the 2nd is 9. Now, here's the deal with this guy, is that it's saying, hey, what power do I need to raise 3 to get this number in here? And then what you're doing is that you're immediately raising 3 to that power. So just like logs and exponents cancel out, exponents and logs cancel out, and that would be your answer. So anytime you have b raised to the log base b of a, these are going to cancel out, and you're just going to get a back. So if we use that property on the next one, 4 raised to the log base 4, 21. You can instantly just cancel those out, and we know that the answer is going to give 21.